welcome to my talk. I also want to shortly say hello to the audience on the screens. This talk is a bit C++ Now specific. I want to point that out directly. So if you want to fully understand this talk, visit maybe C++ Now next year. Short word about me. I've been involved in C++ since '98, and today I mostly work for Meeting C++ and work as a C++ evangelist. Short word about Meeting C++. It's like one more month you can submit your talk, and I also want to point out there's a job section where you can upload your open positions to. And with that, I'd like to start this talk with a short example which got my attention to this whole issue last year. So I was porting from MingW to Microsoft Visual Studio, actually the compiler, not the IDE. And I had this code which uses Boost Factory. It's a bit long and quirky, but it's basically creating a callable which then is actually ends with a type ID in a map. So it's kind of a factory function which we have there, Boost Factory, kind of self-explanatory. Well, and Microsoft Visual Studio did not like it. Gave me a funny error saying here cannot convert widget pointer to widget pointer reference, which kind of makes your head crack. You know, you scratch your head if you see such an error message. You have like you Google the net, and yeah, not so much. And so I thought, well, finally again I can ask the Boost mailing list. And so the Boost mailing list, thanks to Peter Dimov, kind of cleared up this riddle. The problem is that, of course, Boost Factory is not move aware because it's C++03, and hence you get this really useful error message from Visual Studio. And Boost, of course, has you covered because Boost has a forward adapter. So now this code, which was previously already not pretty, is now even more uglier. And this compiled and worked, but it got me thinking, you know, what is Boost Factory doing and what is Boost Bind doing? Well, actually, move semantics, but just build a modern type, build a simple type which does what you want, short template, and yeah, problem solved. And I got rid of a Boost dependency which is not updated to the modern standards. So thought it would be fun to to discuss if Boost is move aware, but maybe anyone wants to join in the discussion?
I'll take a guess and say no.
All right. Yeah, it's kind of true. But also I feel like that I'm not the person to discuss move awareness and move semantics at C++ Now. But if you want to be that person, be my guest, I happily sit in the audience and watch your talk. But with that first example, we saw kind of the problems which Boost causes with the old libraries in the new standards. And sometimes this like really gets a bit quirky with the error messages, and you have to write to the Boost mailing list, and then we're happy to still have lots of experienced Boost members who actually can kind of find out, oh, that is this or that. And which maybe also know Boost a bit better than yourself. But let's get started with the actual talk. I've actually chosen a different example to discuss this. This is an example which is more friendly to beginners, which is easier to understand, because move semantics is, I don't know, seems sometimes a bit esoteric to me. So I think at the start of this talk, I should first define kind of what is cutting edge C++ for me, and I specifically kind of, this is a great image to kind of see like the long effects. It's like when your code is so cutting edge, it makes you want to cry, or makes you want to cry later because your code has become now a legacy, and there's lots of code in Boost which is legacy today, but we still depend on it. And so this talk is exactly about how our sharp tools from yesterday are today not anymore in a very good shape, and what can we do about it. And so this was like kind of the motivation for doing this talk. There's also there's some other motivation which I come later to. And I was looking, kind of how to express this in an image, and I found this perfect image. This is a knife, which is also a gun. So if you ever want to bring a knife to a gunfight, choose this one. And so kind of, so just to build up the context and the mindset to understand what we're not going to talk about. But also I want to say that, cutting edge is like, this is a culture here. This is our culture at Boost and at C++ now, and this is what we're living. That's what the talks are about. This talk is a bit different because we are looking at the past and not at the future. But I think it's something positive, and I'm not here like to tell you you shouldn't do that. But also I think that we should, reflect on what we're doing and how we can transfer this cutting edge into something which is more accessible for the usual C++ programmer, which is not living at such a high elevation as Aspen is. And I think we can all agree that this is unmaintained and old code in production is bad, and if it's cutting edge, it's especially bad because the set of people which understands this code is pretty rare. And I think that we are also in Boost seeing these effects of maintenance problems, that we have a lot of Boost code which is old, and there are some people like the MPL. It's like literally the MPL is frozen and not getting updated, not getting maintained very well because nobody really wants to touch the code. So the MPL is a very good piece of code, which is very fine and very nice for its age and has aged very well, and we don't have to do a lot of maintenance on it, but matter of fact is that actually for the modern standards we should replace it, as we will see in this talk. But then I found so part of the feedback from my user group was that I was like very negative about Boost, and it was a good thing, and I was like, this talk is not really about this. And on the other hand, I also want to see, there's communities and libraries in Boost, not in Boost, but in C++, which have especially always been not cutting edge. And when Boost got founded, it was something novel and something good that Boost went for really using the standard. Other frameworks didn't do this. For example, WX Widgets had this nice programming style guide where they basically say, well, we're a C++ library, but please don't use the features of the language. And this is coming from an age when they most likely started the library. And most compilers wouldn't support those features, or those features wouldn't be well known. And that's very good rules for this time, probably, because you would have to educate most of your programmers about how to do that. But today that's not valid anymore, and they actually have also removed those rules as updated. But I've been for a long time a member of the WX Widgets community, and of course these rules have left their imprint on the code base and makes it harder to move into the new standards with it.
I think one of them caught on.
Which one?
Number 8.
Number 8. Yeah. It's not everything. So the comment is one of them caught out, and it's number 8, and it's not everything is bad in the end. It's for the time where those frameworks were starting, it's like a typical example of how this mindset was, and it's like preserved in those libraries a little bit. And the new versions, they have updated that. Another poster child of this is Qt. Qt is a bit different. Qt is from the beginning an idea to implement Java with C++, and hence they've also had their ideas, and they also have been cutting edge. I want to say that clearly. Like Boost has also capabilities to do reflection, but Qt has with the mock systems capabilities to actually do reflection, which is awesome. And for the time, really, really advanced and early. But also, again, Qt is like templates are something complicated, and this is like something for containers, which is also a very popular mindset in C++ communities from the early 2000s, that templates are really good to build containers and nothing else, and kind of just a schema to build up your type in a generic way. And so Qt is basically on that level for template support. And if you want to derive from QObject, you cannot use templates, and you're pretty much out of modern C++. You're in a world where object orientation, deriving classes, reference, semantics are king there. And so I've given yesterday a lightning talk. There's now a library called Verdigris, which changes this, and I'm currently experimenting with that. But in the vanilla, in the official Qt, that's still the case, and it will not change for Qt 6. And if you're talking about those reflection capabilities, when Qt is doing generic things, and they're doing generic things at runtime with variants and this meta object system with the mock builds up, and you can, over a meta method, invoke a method on an object which is known to this reflection system, and then you have your generic arguments, which are then easily, you have basically, 10 arguments, which are just default arguments. And Boost has gone a different way, but a very similar result with templates, as we're going to see. And I already mentioned Boost, but let's have a look at it. First, Boost is meant as it's a kind of its roots are in the community. It's really deeply rooted to the language, and hence hasn't suffered these popular opinions back then in C++. It has gone the opposite way, saying embracing the language, and it's okay if our code is not compiling with every compiler, and we want to use the language, and we want to challenge the compiler writers. And this has been the spirit of Boost for many years, and it's great. But also there's some try and error in finding the right way. So Boost Graph is a very, very nice library. But it has like a unique style. If you ever used it, it's Boost Graph is Boost Graph style. It's very inspired by Alex Andrescu doing polymorphic, doing like designers, templates, etc. But it's from this age, from the 2000s, and also still under maintenance, etc. So it's not dead code, but it's the really invention and innovation for Boost came with MPL. MPL has basically given a core technology to enable Boost for using templates and type lists, etc. And so this is kind of interesting to see how Boost has evolved in its own style, and which has caught on in the community. The graph style is unique, and it's a good style, it's a good library, but it has not caught on in the community, while the MPL, or someone has to say that the MPL is from core members of the Boost communities, so it's not a wonder that it really has caught on. And so, so finally, first release of Boost was just 5 libraries. But also let's have a look at Boost in 2018. So this is a blog post which came earlier this year, which just asks here, well, shouldn't we replace Boost with the new standards? And then they show a bunch of projects which actually do this, because if you only use the low-hanging fruits of Boost, you can change to newer standards and get rid of the dependency to Boost. And a lot of projects which do that do it. This has still a lot of value, a lot of good classes and libraries which are not in the standard, but most people use Boost probably not to the full potential. So these libraries are just then cutting the roots. And then there was also a different blog post about how to start a project in this year, and should you use Boost? And the answer is no, because it's kind of outdated. And anyways, the new standards, it's this vibe that the new standards replace Boost. And also clearly there has always been some hate on Boost. There's this kind of, if you're popular, you also get a lot of people which don't like you. And hence, it's a very popular opinion that all the good parts in Boost with C++17, they're finally in the standard, and we can, kind of put Boost in a museum. But also, I wanna say that in this year, with two libraries which came in the last, not in the last, but in the previous release, with MP11 and Beast. Boost is actually back in the game, and there's a bunch of other libraries with like state machines, etc., which are in Boost and which are great. There's a lot of misinformation that Boost is like only those low-hanging fruits which everybody knows about. There's a bunch of other libraries, over 100 libraries, which most people don't know about. But also there are some positive entries, like this whole series on Boost Agio, doing on a blog. And then for this talk, I looked into TMP and done some experiments with TMP and Qt, and choose the Boost library MP11 for this and Fusion, and this plays very nice and feels right. So also in the video section and Fluent CPP, there was a short series on Boost, actually 2 videos. I hope we make more videos on this about Boost libraries, and here's like one for Phoenix. And so as you see, not much has changed. But if we look, at how Boost has aged, and just as an example, because it's like Boost is not the only popular library which we use in our code bases today. Qt has the same problem. WS has the same problem. Boost has the unique problem that we have this really high-tech code from the past, which isn't high-tech anymore, which is a different kind of technical depth, because the libraries which restricted themselves to not use the language to the full potential of like what was the potential in the past and not the potential of today, don't have this problem as much. They have a different problem, and Boost shares this problem too, because we also use the easy parts of the language, but this is a unique problem to Boost and some other libraries which were influenced by Boost. So as a first example, I chose this, like there's one central technology which enabled Boost, in my opinion, and that is variadic templates. The emulation of variadic templates, the ability to have a type which has a variable list of arguments. And so today, totally easy. Everybody can do it. It's in the language. But of course, in the previous decade before the standard, Boost did have this ability. And it's kind of a bit similar to the Qt function we saw. It's just in a different approach, but it's done in a way which is probably a bit better for the runtime, because most of this compiles and it's not visible at runtime, unlike Qt is doing with like default arguments, so they have to check like how many default arguments you have. So they kind of emulate the generic part of their library on the runtime, and Boost is not doing this, and Boost is with templates there in the area where we can just have the compile cost and not the runtime cost. And the big question is like, how did they do that? So this is how MPL does it. But neither MPL nor Boost provides any service or anything which makes this available as like a library, like variadic templates, Boost variadic templates. It was never a thing, every library does it on their own, and the way MPL is doing it, and most other libraries are doing it, is with a preprocessor, which is then generating files which contain template types for a specific type from 1 to n parameters, and the max n in boost is usually 50. And this is, see the next slide, set with the define, boost MPL limit vector size. So this is individual for every class, every type which you want to have support this. You had to do this. So, and then boost, and generally these libraries are not, this is not done during your compilation time. So these files are coming with boost, they are pre-generated. The MPL does this with some Python scripts. It's actually an interesting question if they're like compatible with Python 3, I don't know. But anyways, those files exist and they're generated, and if you need more than 50, and some people need more than 50, that's, you can find interesting threads on the internet about that. You can kind of run those scripts with 50 or more. But if you look at those files, I'm actually not sure what CTPS stands for. This is like the first file. There are 3 different flavors which are generated, okay? And which are probably supporting different compilers. And this is the first one. I always choose a vector 20 as an example, just to pick something which is like a kind of in the middle. And then you have a code file which is basically doing this 10 times, and it's 1,802 lines of C++. And this file also includes, of course, the vector 10 file. So actually, if you need a vector 20, you get over 3,000 lines of C++ included in your build system, and that makes your compiler very happy. But this is probably like some weird hack for some compilers which couldn't do certain things. Then they have a plain version, which is a bit shorter. It's just 1,145 lines. And this is a version which, in my opinion, because it's type-of based, and it's literally also named type-of, which modern compilers will pull in if you build anything which is related to the MPL. And it's just 160 lines of C++. So it's a tiny file, but of course you include the vector 10, which is also 160 lines. And so if you really have heavy code which goes deep in those hierarchies with MPL vectors, you're going to include a lot of C++ files which are generated and are just an implementation detail which most people never see. And what if you look at other libraries? Fusion is very similar, and Fusion actually has a dependency to MPL, but they also have done their own things. And here's the good news. Fusion, it's a bit newer, and Fusion is like maybe also maintained by a different set of people, and so these people are still active. Fusion actually has had the ability added to use various templates, but this is only true for, as far as I know, only true for the types which Fusion itself has. So Fusion is built on MPL, so the MPL types which Fusion uses are still in the O3 world. But as is also template metaprogramming, like my previous example with move semantics, does not apply here because we are just living in a type world, which just gets down to some real world types later. Fusion is doing the code generation very similar, but they choose to do it in a bit a different way. Though Fusion does not use Python scripts, they didn't update the Python scripts like they could have from MPL. They actually use an approach which uses boost wave and boost build. So, and also files are today generated and are just shipped this boost. I guess we don't have a problem with that, but we're moving away from boost build. I don't know how many people today know still boost wave. There's probably very few. So changing this code is probably, if those people who maintain it currently, it could get very hard. And let's have like, and Fusion is just generating this once. And if you use C++11, your compiler will, as far as I know, not see this code. But the vector 20 again, and it's 1,825 lines of code. It's a lot different than what we've seen in the MPL. It's doing things a bit different, and kind of see a boost constant expressions about. So this code has seen some love from the new standards. But as far as I know, if you use the newer standards, I have the opinion that your code shouldn't be seeing this, and I hope to be right. But that's of course not like the only libraries which have done this. There's a variant which is updated to C++11 and uses variadic templates today. Tuple. I looked in the header files of Tuple, and I have the opinion that it doesn't use C++11. So but Boost Tuple has, I think it just supports 10 members. You cannot, or 20. So it's not as big, and it doesn't have that generated. It's just one header file where it's like typed down. And yeah, there's a few others which also have kind of tried to simulate that pre C++11, and but as I said previously, Boost never had a central library to kind of offer it as a service. So you could like include this and make your type variadic. So because if Boost had done that, could do this. Oh, I don't know. I have no idea how this would look, but we could kind of have a way to automatically change this one library and make it support variadic templates, and then but no one had this foresight actually in Boost. And I think it's really interesting because these people are the standards people. They should have known that variadic templates is an idea which would be coming.
Well, I think my guess is it wasn't so much no one had the foresight, but no one had the ability.
The comment is that no one, it's more like that no one had the ability to change the code.
No one had the ability to make it generically useful for many libraries
Yeah,
at that time.
yeah. That is the interesting question, and I agree with that. Is that even possible to do in C++03 to have like one central service to do it? In my opinion, a very easy way to do it would have been to just write a code generator. And like, we have seen that this technology has been implemented with different ways in Boost, so the knowledge was there. We could have done it, but of course it's also this is a library which is useful to library writers, but itself has not a single purpose. You cannot do anything with this library. And if it's a code generator, it's not even a library. It's like a tool application, and people have different opinions how this should look and how should it be implemented. And a few years ago, I got a very interesting comment that writing tools for Boost is not really worth it because you spend a lot of time doing it, and then you have people still review your code and your tool implementation, and maybe you get accepted or not. And other communities in the software world make like the reviews for the code, but not for their tools. And maybe Boost could learn a little bit there from KDE. And to wrap this section up, so as I said, very, very central innovation in Boost is the ability to have template types which have different amounts of parameters. Basically what we see today in Fusion and MPL, and what we have today as variadic templates. And there's a lot of libraries in Boost which use MPL, and it's a very core and central technology to Boost. but MPL has not moved to C++11. There were debates about that, and the general agreement in the community was maybe not. And Fusion still is under maintenance and is doing a better job here, but Fusion depends on MPL, and I think Proto also depends on MPL, so the core libraries in Boost are dependent on this one dependency, which is not being moved to the new standards, and this slows down Boost in my opinion. So, any guesses what this example number 2 is? Of course. What do you use Veretic templates for? You do TMP. And now we can just have a look at how good the new standards have become in doing. This is the 50 bar, this is how far Boost goes, and the modern libraries are like 400, 500.
I have no idea what the axes on these graphs are from this distance.
Yeah, I know. This is so the exercise. I know I have to explain this graph. So this question is, what is this? So this is the Meta Bench website where you can compare different algorithms at compile time with different libraries. So you see here, this axis is the number of parameters in your Veretic template or in your type. And as I previously said, Boost ends at 50, and the modern libraries can go to 10 times as that or even more. I think Odin is saying, I can use 1,000 or 2,000, but who wants that? And so this is COUNTIF, and this is add. And as we see, add is kind of relatively cheap. We see here is like a little hump, and we end at 50 with Boost, and then we see it's like, but there are some algorithms which are not as cheap, and we see that the compilation time for Boost goes up, and basically everything, this graph shows you very clear that everything that depends on MP list or MP vector, which are those two types, is compiling today still very slow. It's just, so this is on Clang 4. Probably you could use a newer compiler, but difference wouldn't be very much. Probably the other libraries would be even better. Yeah, and the other libraries which are in here is like Brigand, Quasir, Meta, Metal, MPL11, MPL, and MPL has two types, and the modern types only uses as list. And if I go into the, so TMP, I think everyone knows what TMP is at this conference, but I wanted to include this into the slides to have, so that everybody can have a chance to understand what we're talking about. And there was also a nice introduction at my conference last year in Meeting C++, so if you're interested in getting an introduction into TMP and how it's done today, that would be a good video. But let's talk about TMP and Boost. So TMP is the ability to do type-based compilations and value-based computations at compile time. And you can use that with various things, and the MPL has provided this. I'm going to talk about the MPL just in a moment. And yeah, just let's continue to the MPL. So the MPL, basically the motivation and also the name hints at it, is the kind of the STL for template metaprogramming. It's very similar. It has map types, it has a vector, and it's very, very deeply inspired by the STL. But as C++ has no support for doing type calculations, like with containers which contain types instead of values at compilation time, hence the MPL was written and invented, and this is a great innovation for C++ And this is definitely also inspired by Alexandrescu, who showed in his book, like, hey, you can do typeless, and this is how you do it. And I guess this is just from a general time from the early 2000s when people started playing around what can you actually do with template metaprogramming. And one example we previously saw, like you can calculate certain values, like you can calculate a factorial, or these are the usual toy examples which people use to introduce you to it. But the MPL can do way more and can do very interesting things. You can like have complete lists and compare them, and this is basically where everything builds up on. And then the MPL has not only the containers, but the MPL also has the algorithms. So you can, as we previously saw, do a COUNTIF or an add, etc. on those containers which are type-based. But Boost also has a different library for doing TMP, and that's HANA. And HANA is kind of the new innovation and has been very popular at C++ now and is now for some years in Boost. And Louis has done a great job in providing us with this great library, which has been very popular and is very popular, but also has been a little bit controversial because Louis goes a different way. And I think what has been the interesting part about HANA is that Louis could show us that the way he went was like very, very efficient and was working well better and was actually the better way to do type-based programming on compilation time. And that there's like a school of TMP today which thinks differently, which does not necessarily want to mimic the STL for template programming. So HANA is going in a very interesting section there. So what we saw with the new standards, new ideas came, but HANA was not the only library which was being here innovative. Actually, somebody where nobody knew, Odin suddenly was there, and he was like, what about aliases? I think I have a good idea here. And Odin and a few others have actually done a lot of work to use varied templates and to continue a bit more in the style of the MPL to have type-based metaprogramming. And these are like three libraries, Brigand, Quassia, and Metal, and Quassia and Brigand have heavy contributions from Odin. And also in this group belongs MP11. There's one major difference to the other libraries which we previously saw. MP11 is since this year in Boost. I want to stress the MP11. I've just been playing around with this library. It's a very nice library. This library has the ability to replace MPL. And this is kind of the way to go, in my opinion, right now. Because if you wait, like there's some other innovations for TMP also coming to Boost. Odin presented some ideas of also submitting a library. But MP11 really mimics the MPL very well, and it could offer us a way to support template metaprogramming, which previously is MPL based, and the new standards with a new library which would make the compilation speed of Boost a bit better. And just, we can't get rid of MPL, we can't deprecate it because the old standards still need it, and there's a bunch of people standing on C++03 and never changing. Those people exist, they just don't come here. But for the new standards, I really think that Boost should make a big effort to make sure that MPL gets its place in a museum, and that's where it belongs. But on the other hand, if we talk about culture also, the Boost culture is that like every library author has the authority to decide what to do and what not, and replacing MPL with MP11 probably is not a fun activity. But we have the software conservancy and we have different ways of doing that, and I think that there needs to be a general discussion in Boost. How do we maintain those libraries which actually are, so heavily dependent for so many code bases? And this is the model that a single implementer that kind of gets to own his library in perpetuity is still a good model to go on. And maybe we should after 5 years, make a rule that an author still kind of, gets to have the say, but maybe there's a maintenance committee which also, is doing work and is able to help him maintenance work. And also, this with every new standard, every new library will have to do new things. And this is very, very clear that the maintenance in Boost will have to be much, much more than it is today if you want to keep up with the new standards in this library. Which, of course, as we see, many library authors don't, or the code just moves somewhere else or gets replaced in an easier way. But also, if you've been last year here, it's kind of clear that TMP has peaked. TMP was never like a very popular thing to do in C++. There's like Herb Sutter, I think, it's a quote from Herb, saying, well, everything you can do with TMP, you should be able to do with a language. And so TMP is a nice way to do it, and we all see those nice libraries in TMP where you can do really, really nice things. But now it turns out there is something new, which is constant expression, came also with C++11, and people have looked at it and found out, well, actually, we can do a lot of things with constant expressions, which we previously did with template metaprogramming. And it's just the case that actually also the new generation of programmers, which is coming to C++, they will start with constant expressions. And so TMP itself could face this maintenance problem that the code itself is actually being, replaced with newer standards, and maybe TMP is the Verillic template of tomorrow. And yeah, so last year it was always clear that you could do a lot with constant expressions, but who cares? Well, last year we had this awesome talk which showed us that you actually can write a constant expression JSON parser. And so constant expressions are, I think, completely replacing TMP if you have to calculate values at compile time. And for every work where you have types and type lists, TMP probably will still be an option, but constant expression will have its addition to TMP. So I don't think that constant expression will make TMP completely gone, but
the type list side is heavily covered by Verillic templates.
Right. So the type list side is heavily covered by Verillic templates, and I agree with that. And there's other things which cover us there, like fold expressions, etc. So we have a set of new tools to do programming at compile time, and TMP is definitely a nice way to do it, but there are easier ways to do it, and we probably soon don't need the library to do certain things there. And yeah, so with every new standard, the constant expressions are going to be better. There's even a constant expression new or allocation for constant expressions in discussion, and probably in C++20. And also, it's much more friendly on the compiler. So the compilation times are.
If constexpr has made a huge difference for me.
Oh. So the comment is on my next slide. Yeah. It is, in my opinion, you shouldn't look at if constant expression. It's just if you're not able to use C++ 17, don't look at this. It's just, it makes the code so much easier. It's one of the best features we have in 17, and it makes you cringe when you have to write enable if again. So we see there's a lot of innovation, and we learned a lot through the libraries which pioneered this through template metaprogramming. But yeah, so this all has been moved to the language, and there's also very, very many people in the committee which say this should be in the language, and it should be easier to understand for the compiler, and it shouldn't be in the type system so much. And one of them is Herb Sutter, and there's a few others. And so also, it's not that like Louis, which has written HANA, is like opposing this. No, a big factor in that is Louis Dion, who uses his experience with writing HANA to have general advice for the standards committee where to improve. And so many abilities which HANA has today, which are unique, are going to be in the standard. So Louis kind of works on his own legacy in the standard to replace this library. And there's a few other people here which do similar things, which write libraries to understand how you can do that, and those libraries will be very useful. Like yesterday was a presentation on Argot, which is a library which helps with function calls for variadic types, not for variant types and for tuples, and also for futures maybe. And Matt's motivation for this is also to see how we could that have in the standard. And so you're basically making visit with that a bit better for variants. So there's solutions to the problem, maybe, or not. That's so my main motivation for this talk, and the most talks I do is on these topics. It's not like to give you 100% solutions. Like just, could we start a discussion on this? Could we have some people think about this? Because I think there's a problem. So let's first focus on Boost. Boost has a lot of problems, and Boost has a lot of advantages. Boost is a great thing, and we all love Boost here. It's like, if you don't like Boost, it's the wrong place to come. And it's not so much that the cutting edge is the problem. It's like more to keep this cutting edge sharp and rust free, and to handle the maintenance costs, to keep the tools sharp, to also adapt to that. And also it's like a similar thing as like Boost is not prepared to hand over something to the standard. Not at all. The old libraries stay in Boost, and the new libraries get re-implemented in the new language, so the new libraries are definitely better to use. So people moving away from Boost because all their dependencies have moved to the standards, they have their point. I can clearly see that. But also maintenance in Boost is a community effort, and other libraries have paid maintainers, so there probably is an edge for that, but Boost has a different problem there. And then for me, a central difference between Boost and standard versions, I know they exist, but Boost should have like a documentation on that. Like, where is the Boost type better? Where has the Boost type abilities which had to stay in Boost because they were not going through standardization? And I do remember, like for shared pointer, that the C++11 version of shared pointer could not handle arrays, while Boost could do it, and this was the case that they just had to trim this feature from the standard because standardization was already very, very heavy on this. Boost also needs a better documentation, and the other thing which I really Boost gets to have a problem with its own success, because Boost does not have the ability to use these new standard types, which are, if you're in the new standards, preferable. So if I use one other library which is in Boost, like those great libraries like state machines, which you don't find in the standard and which are really well implemented in Boost, I get to interface with the Boost types. The same as with I use Signal2, it's also a very good Boost library. All the interfaces in those libraries are hard-coded to Boost, and I do not have any ability to tell Boost, please use a standard type instead of your own Boost function, instead of your own Boost shared pointer, instead of your own, all the things which are going to the standard or which have already gone there. Boost is not able to interface with those types, which are kind of the new and better implemented libraries of their own versions. Boost stays behind here, and there has been, in the last years, I couldn't see a single effort to change anything in that direction, to maybe update Boost config to allow to change to each new library, which is in the standard also for Boost libraries. And I think this is which would be very practical and very useful to have. But again, then there is the problem that every maintainer has maintained. So maybe we really need to have a central design idea about what Boost should be for the future and how we can adapt our own libraries in Boost to the new reality which is there, and which hasn't really been debated here at this conference, which I find interesting. That it's like we keep moving on with Boost and we keep doing our reviews, but like we don't have this debate about like where should Boost innovate again, where should Boost move, how should Boost handle its own technical debt. And so I'm very happy that I this year have the ability to stay a bit longer on the conference and actually see the future of Boost session, and I'm going to probably want to discuss this there. Of course, we cannot ignore the standard on here. So on my blog, I actually was doing research for this talk and I found this by accident, this idea to have standard blocks. It's like here you have a block which has a certain name, and everything in this name is like only seen by the compiler if it's like on this standard or beyond. And you're probably going to like this idea much more if I tell you that this idea comes from Sean Parent. It's not my idea. So Sean thinks this would be like a possible way to go, but of course we have there also the backward compatibility problem, that we would have to do it in a way, like, I don't know, but we would have to do it in a way that is clear that this code is only compatible with the future standards there, and C++ 17 is already out of the door, so this will not happen. But we could kind of introduce kind of something like this in CPP 20 and make this just be available. I'm not sure about this debate, about this idea, but this comes from Sean, though I think it's worth mentioning, and also it kind of plays into some ideas which Eric Niebler had in 2013 already in his keynote, where he showed like versioning namespaces and how he would like build modern libraries. So
it's an idea that's been tried out in some other languages, but all of those languages seem to be too young to tell if it really works yet.
All right, so the comment from Lisa is, there's an idea which has been tried out in other languages, but there's not enough experience in the field currently with those languages to tell if it's a good idea or not. And yeah, that's always a problem if you want to have something new and are not sure if it's a good idea.
Well, this is an idea that is going to take like 20 years of experience to know if it really works well.
Well, Lisa comment said like we know in 20 years if that is a good idea or not, and I kind of agree with that. But in 20 years, I guess if we were to introduce it today, we would know in 20 years that it's a good idea. Maybe it's just Stockholm syndrome, but yeah. And then of course, macros and aliases. Aliases would be really good example. Using is a great addition to C++ because unlike type def, it supports templates. So that would be like the way for Boost to go to offer an alias to its own types and make define where you can Boost use STD11 or CPP11 or Boost use shared pointer 11 or STD shared pointer, just how you ever want to spell this, I don't know, and go over like the preprocessor and make sure that then the correct type is chosen. And then customization points. This has become very popular to provide customization points in the standard to allow other people to adopt the libraries to their needs. And also I think this is a useful idea for this problem. Even of course it has its limitations because customization points can just customize what the points allow. And there is then also that C++ is now a dynamic language. And I think this hasn't fully catched on to our community, especially like, I think that the programmers know that, but there is a bunch of new ideas coming with tools. Google has done really some great talks how they, use these new abilities to do basically maintenance on their code base automatically. And every 3 years we have a new standard, and every 3 years we should switch our projects to either the previous standard or to this new standard. And it's probably pretty hard if you're in production, but I think this is something which, especially the decision-making layer, the management layer, which is responsible for the work environments where we work in, hasn't really caught on. And this is like, I think for the language a big problem because there's a big possibility to make C++ a lot better and to have like just look at C++ 17 at 14. It makes your day as a programmer so much better, and also your productivity goes up. So it's no way to have this mindset that you stay on a standard for 10 years, which we had and we still have in a lot of projects.
Well, at the very worst, we can make progress one dead project at a time.
Yeah,
so science does.
So the comment is at the very worst we can make progress by one dead project at a time, and yeah, it's of course we're gonna see that people move on, and that's actually also feedback which I have heard from many people I have met during which are like in hiring, and they're saying, well, we have no problem finding programmers for our new projects, but finding actually people willing to work on old maintenance code, on old code bases is like really hard and not very popular. And also the problem is that the language, as it's now dynamic, and we have actually every 3 years a new standard, it's changing so much that the old code bases, which are, if they're not maintained, if they're not brought to the new standards, are in a standard which is not really able to be understood by the new programmers. And this problem, of course, also lurks around in every of the widely used large libraries like Boost, Qt, WX widgets, etc. Then also, I want to speak a bit about the conference and culture which we have here. Let's start with something positive. This is a great conference. It's very welcoming, and a lot of people come here every year, but most of them come back. And we're not sold out for quite years, So last year, we had a talk, which actually was awesome and great, but as I'm also on the program committee, I read this talk description and I was like, if those people who make the decision to send someone here read this talk, they might think we're completely crazy because we had a talk last year basically on a library which calls a function. And if you didn't really understand the talk description correctly, you probably would think, what's wrong with you? I never needed a library to call a function. And as you know, we kind of recruit the program committee from the conference, and the people which come often here are in the program committee. It's kind of getting into a self-selecting process and self-optimizing process where this conference becomes more and more advanced. And well, this is on the one hand, as I said, being cutting edge is good, and this is what this conference is about. But I'm also a bit worried that we cut off to make this conference interesting for new people, which are into the intermediate sector, which came here. None of us came here as experts. We came as people who wanted to learn and who came here to learn. And so I think that there definitely needs to be a bit of a debate on how to make this conference a bit better again, how to make it maybe a bit more attractive to come here, how that we sell out again. I remember times when C++ Now was sold out in days. And I'd like to go back to that, to a time where really this is a thriving conference, and it still is. We have a lot of new people, and it's a very, very nice and very welcoming conference. But I'm a bit afraid that we kind of become too esoteric and too much into the way of doing C++ in a way that is too focused on cutting edge. And this year, it's not as bad as it was last year, but in my opinion, one talk which I really, really liked was Olien's talk on mix-ins, because he also showed that his position and his perspective is not purely academic. It's not like this is my paper how to solve mix-ins. No, his perspective is also that he has a use case, that he's able to not only to use this in production, or his aim is to use it in production, but he also at the same time understands that his team has to use this. And I think that is something where especially Boost sometimes has a bit of a problem, that documentation is a bit lacking, and sometimes the understandings of that code needs to be applied to real world problems. So I'd like to have a bit of more reflection on that in the talks here too. And with that, I'd like to open the debate.
You told that we need to not to be on the cutting edge at this conference, but what then should be the talks about? So if you
so the question is, what should be the talks about if they're not about cutting edge? I explicitly said that I think that cutting edge is something good, but we have 3 tracks. So my opinion is that we not should only focus on cutting edge, because this code will not age well. My opinion is that we should really, really, really start reflecting on how do we transition this cutting edge code into a form that is usable to the daily C++ user. And I think that these cutting edge talks might not be that interesting, or might not be that able to be followed by people which are on the intermediate level. And we also have to understand, I run a conference myself, so it's not always like the programmer would probably also like to go here, but the decision of the programmer is able to come here, like if she can attend here or if he can attend here. Other folks make this decision, and they probably look at the website, they look at the talks, and if it's like they cannot see the value of sending someone here, then as a conference and as a community we have a problem, because I think this conference has really done a great job in bringing people into this expert stage where they can do this cutting edge, and I think this is something good. I like the talks which are here, but we should not also see that we have a role to kind of to teach the next generation and to bring them up here. And currently I see that, you know, we have a lot of unused potential. There's I think like 20 people which could be here which are not, and in the past when CPPCon didn't exist, the conference was sold out within days. And this conference has evolved from BoostCon, which was a community-based conference for Boost. And we've moved from that to a very library-focused conference, which previously already was there. But I think that if we continue to go this way, if we become even more cutting edge than we are now, I'm afraid that the conference becomes too esoteric, and it will be hard to draw in the audience which will then give the talks of the future. Because it's kind of, it's nice to see the same people doing great talks every year here, but we also have to see that we get new talents. And right now I know that a lot of the people which we actually recruit and which we actually have being the talents which thrive this conference, which give talks, are coming through the volunteer program, which is kind of the way to recruit the new generation for this conference. And on the other hand, we should not underestimate that this conference is already C++ for the privileged. It's not easy to get here, Aston is expensive, and we're already having, it's like the location, once you've been here, you love it, it's great, but it's not really an advantage as a conference. And if we like keep adding things which makes it harder to sell my trip to this conference to my manager, this conference is going to have a problem in the future. And this is like something which I saw last year. But one thing I noticed this year is that also it's kind of, for me, hard to see how interesting the talks are for the attendees, because I'm very well informed. I do read blogs every day, and for a lot of you, this conference is the ability to see new ideas, which always has been the thing of this conference, and which I like, and I sit here in the talks and do the same thing and like the discussions. But I think that we also should have a reflection on how to deal with the maintenance of the code we write, and how to actually maybe really reflect on this. And we see that some people like Louis or Matt are explicitly going in a direction where they are saying, I want to write the library, and the cutting edge ideas I have from that I apply to the standard, which is the other way to make it usable for the everyday programmer. And
so this is my first year at the conference, so maybe I could offer just at least one data point on the talks that, the reason that this seemed valuable to us was last year's talk, like there's one on CMake, like tooling the infrastructure, yeah, practical things. One on CMake, and another one, Matt Gombold's talk, just on his tool. And there were a couple other ones kind of along those lines. And so in one sense, it supports your point that those things, rather than the new esoterica in the language, are valuable. But on the other hand, they were already here, right? So that, there already was some of that at the conference.
Yeah. So the comment is that part of that has been reflected, and yeah, I agree with that, and I think that this year the conference is not only better in the weather but also in the program than last year. But this is also a point where I say this is what the conference should be like. You know, we should have like, there should be like one track which is not like really focused on being cutting edge. We still can have 2 talks on cutting edge. Nice. But as a conference, you can only accept the talks which get submitted. And if we do a bad job in reaching out and getting people an idea what they can submit to this conference, and this conference is like explicitly saying we're only about cutting edge, we might just have the problem not to get these talks because people are not able to come here, because it's, again, I'm speaking here, I don't have to pay the ticket, but I still have to pay my travel, which is expensive. And there's a lot of attendees which also are coming from international locations. And I myself coming from Germany, and so it's a thing which really definitely needs to be reflected, as Boost needs to reflect on its own history. The conference has to do the same thing, in my opinion, which is kind of the core motivation for me to give this talk. To just, we should start reflecting on what this should be, like Boost and this conference. I think the conference is on a good way. We had a very interesting discussion on the programming committee yesterday. And I agree with your comment that this year is a lot better in the program that we have. Like, last year we also had a talk on CMake. Okay. Any further questions? Comments on Relay templates, TMP?
Would workshops teaching intermediate programmers more up-to-date concepts be something that might draw more people to the conference?
The question is if offering workshops and doing more teaching about standard features or Boost features here would draw more audience to the conference. I believe so. I think this would be a good way for the conference to go. Maybe, I don't know, CPPCon offers classes, but maybe we could explicitly make a call on having a workshop-like talks where people learn the new language. That's also the central thing when you have a conference. You kind of have to think on how to get the people here to make them attend. And there's 20 people which could have attended this conference. We only have 150 spaces, and this is kind of, I think it's a reachable goal to sell the conference out again. This should be the goal, and we should see what can be changed in the conference for that. And I'm specifically just want to say again, I don't say that we should stop being cutting edge. This is something positive, something good. This is the spirit of this conference. I don't want to change that, but I think it's really time to, after 20 years of Boost, to reflect on what can we see and what can we learn from the code, what was yesterday cutting edge and what is not cutting edge anymore today. With template metaprogramming, we are seeing that the peak is also there, and in 5 years you're probably going to have a different opinion on template metaprogramming than we have today. And so I think, yeah, it's a very good idea to offer workshops to help people come here, to help people to sell it to their managers, because I think there's like nobody would just like not want to be here. And I know a few people which are coming here instead of to CPPCon because it's much more relaxing to be here and much more. The conference itself is very nice. And that's why I'm also coming back every year since 2012. So. Thank you for your attention, and maybe see you next year at C++ Now.